So today we'll study something about what trie is. It is quite frequently asked in interviews, and it is also known as prefix tree. So what it does is, it is actually an information retrieval data structure. It is an information retrieval data structure. And as you can see, why its name is trie is because of this. Trie is because of this retrieval data structure. And you'll see it actually makes a search of some word in big O of M time, where M is the length of word. The penalty of searching a word in big O of M time goes with the storage of trie, as we will see how the storage is moved. Suppose we have some words like car, cards, card, and some more bull, bully, etc. Suppose we have these words. So what we'll do is we'll store them in trie one by one. Let's see how we'll store them. So here's the root node. It will have 26 children from 0 to 25. The 0 represents 1 A and capital A or small a, and 25 represents capital Z or small z. There will also be one bool word which will tell us if word is completed or not. So if it is false, it means that current node is not a complete word from the root, and if it is true, that means the current word from the root is a complete word. So we'll see how we'll do it. So let's add some words. So there will be C, A, R, D, S, and then here B, U, L, L, and Y. Let's take one another word so that we'll understand it better. Let's take cars here. So what we'll do is C, A, R, and S. So if the word is completed, we'll mark it as star here, just for visual representation, so that we don't forget it is a word. So now these are all the words. So if I want to, so it is fast, because what I'll do is, suppose I want to find some words which starting with car. So it will just come on C, A, and R. Then it will print all the words down it which are completed word, means which have star on that. So it will print car, cars, card, and cards, like this. So I can also search if a car word is present or not, if care word is present or not. So it will come here C, A, R. It will see that care is not present, so it will not say that it is not present. Suppose I search for a word CA, so it will come on C, then on A. It will see that it is not marked as completed word, so this word is not in our dictionary. So we have three functions here: insert, second is search, and third is delete. So we'll see one by one. So how we'll insert it? So if we'll insert a new word, let's see how we'll insert a new word in this. Suppose we want to insert care word in this dictionary. So what it will do is, it will take one by one. It will see, okay, C is present, A is present, R is present, and E is not present. So what it will do is, it will create a new node E and mark it as star. And if we see again that if I want to add CA, it will go on C, it will go on A, it will see that okay, this is not marked as star, so it will mark it as star. And now CA is also a word in this. So insertion is easy, and it also takes big of m time, because we only have to go from to the length of the word, and then we have to make a new node and insert it if it is necessary. Otherwise we just have to mark it as completed word. So let's see another function, which is search. So we'll see search function for this. So what we'll do is, so we can see that if we want to search some word, for example cars, so what we'll do is just see C from here, it will go okay, C is here, then it will go from C to A, then A to R, and R to S. So it will see okay, this S node is marked as star, so it means this is all word is present in our dictionary or our trie. Similarly, if we want to search for a word care or some word, suppose CA, we'll see it one by one. So suppose if I want to search a word care, what will happen is C will come on C, then A, then R, then you'll see that there is no node as E, means the E node is null, so it means this is not a word in our dictionary, so it will say not, this word is not present. Similarly, if I want to search CA, it will come on C, then A, and as it is not marked here as star, so it will say that this word is not present in our dictionary. Simple enough. Let's move to delete. And delete is somewhat what we call is, it has some conditions. Let's see what conditions are there. Let's copy this. So it has two conditions, that the word which we want to delete is not a prefix of some other word. Second is prefix of some other word. So let's see first condition. If the word is not a prefix of some other word, in this if we see that cars, if we want to delete cars, then it means it is not a prefix of some other word. So how it will delete is, it will come on C, then A, then R, then S. So on coming on S, it will delete marked its marking, and it will come here and it will see that okay, it will delete S, because S don't have any children, so it will delete this S. It will come on R, it will see R has any children, yes it has D, so it will not delete the rest of this. Otherwise, if this would not have been present here, then it would have deleted all the words from RS, all the words CAR, it would have deleted. Let's take another example. If it is a word, it is a prefix of some other word. This one is quite simple actually. Suppose we want to delete card. So if we want to delete card, it will come here CART. So it will first remove this mark, and then it will see if it has some children. Yes, it has some child. So it will not delete this node. So this node remains intact. This is how we delete and trie. I'll come back to you with some video or some program on how to implement trie in C++. I hope you enjoy this. Thank you.